39, perform the indicated operation and simplify. So we've been given 3 over y squared minus 3y plus 2 plus 7 over y squared minus 1. So notice that although the directions haven't changed, the operation that we are performing has changed. We're no longer multiplying or dividing, now we're adding. And so when adding rational expressions like this, what I like to do is, because there's no equal sign, this is not an equation, I like to go ahead and stack my original fractions. And because what we're going to ultimately end up doing is coming up with a common denominator and then combining these two fractions into one. And so I like to, as I said, stack my fractions because it helps me to stay organized. So 3 over y squared minus 3y plus 2, and then we have 7 over y squared minus 1. All right, and from here, we're going to build a common denominator. And so in order to do that, what we first want to do is go through and factor each of these denominators. So this y squared is going to factor into, well, let's see, there's no GCF, and we have a simplified form of either scissors or AC or trial and error. So we're looking for factors of 2 that add to negative 3. So we have our y, and how about minus 2 and minus 1. All right, and then down here we want to also factor, this is the difference of perfect squares, so we're going to have a y plus 1, a y minus 1. And now when we build our common denominator, the reason we want to have our denominators factored is because we need one of each factor that's unique. So looking here, we have a y minus 2, a y minus 1, a y plus 1, a y minus 1. So let's see. We know that, like I said, we need one of each thing that's unique. So y minus 2, y minus 1, and let's see down here. Well, we already had a y minus 1, but we're missing a y plus 1. So let's go ahead and add y plus 1. And it looks like that's it. With y minus 1, y minus 2, y minus 1, y plus 1, we have all of the possible factors covered. So that's going to be our common denominator. All right. And now what we want to do is figure out what we have to multiply by in order to combine these two fractions into one. Because if we started originally, and we're going to start here in the bottom fraction, if we started originally with a y plus 1 and a y minus 1, but we know that we're going to the common denominator here, what did we have to multiply by in order to get this common denominator? Which factor were we missing? Well, y plus 1, y minus 1, y minus 1, y plus 1. So the one factor that we were missing was this y minus 2. So in order to get from the original denominator to our new common denominator, we are going to have to multiply by y minus 2. And whatever we multiply the bottom by, we also have to multiply the top by. So let's go ahead and do that. And so now we have 7 times y gives us 7y. And 7 times negative 2 gives us minus 14. All right, and now we're going to do the same thing here with our top fraction. Y minus 2, y minus 1, y minus 2, y minus 1. So we're missing the y plus 1 factor. So to go from the original denominator to our common denominator, we have to multiply the bottom by y plus 1. But whatever we do to the bottom, we also have to do to the top. So now we have 3 times y gives us 3y, 3 times 1 gives us plus 3. And now that we've built a common denominator, that common denominator can just kind of move on over as y minus 2, y minus 1, y plus 1. And now the numerators can go ahead and combine. So we have 3y plus 3 plus 7y minus 14. And now let's go ahead and combine like terms here. So 3y plus 7y gives us 10y, and 3 minus 14 gives us minus 11 over that common denominator, y minus 2, y minus 1, and y plus 1. And there we have it for number 39. So again, when you are adding and subtracting rational expressions like this, what you want to do is, at least what I like to do is, because this is not an equation, right? There's no equal sign here. We don't see any equal sign. I like to stack my fractions. And from here, I then factor each denominator so I can see what fraction or factors rather make up the denominators. And from there, I build my common denominator, multiplying each numerator and denominator by whatever was missing. That common denominator then comes over. I then combine my numerators and then combine like terms and hopefully get something is able to simplify down. Now, if our numerator was able to be factored, you would want to factor the numerator because there's a possibility that the new numerator, once you combine like terms, can possibly cancel out with something in your denominator. In this case, 10y minus 11 can't be factored any farther, so we're going to go ahead and stop there. But just be aware that you may have to continue. Once you've combined your numerators and then combined like terms, you may be able to factor that numerator one last time, and by virtue of factoring that last time, you'll end up being able to cancel with one of the factors in the denominator. But that wasn't the case here. So 10y minus 11 over y minus 2, y minus 1, y plus 1 is our answer for 39.